Hello, everyone. I'm back again to drop another lovely episode, and this time I had the pleasure of interviewing Professor Aleksandrina Skvortsova, whom coincidentally enough was a postdoctoral researcher during this interview, but the day after became an assistant professor at Leiden University. Her research focuses primarily on how expectations, beliefs, and attitudes impact one's health, mainly concentrating her efforts on placebo and nocebo effects, which we talk about extensively throughout this episode. Additionally, Alex is a project manager for the Framework for Open and Reproducible Research Training, FORRT for short, where they aim to advance research transparency, reproducibility, rigor, and ethics by teaching, mentoring, and raising awareness on science replication, a topic that is quite important in our field. Their website and Slack channel are available in the description. During our conversation, we do a deep dive into the placebo and nocebo effects, how it affects humans and animals, what is its neurochemistry, and what do their future studies look like. Additionally, we discuss in length as to what other ways placebo/nocebo effects can be investigated by ways of diabetic patients and measuring their insulin levels. A key takeaway from this conversation is that the research in this area is vast and has both an element of discovery and precision. Discovery being the advancement of new knowledge and precision being the careful application of that knowledge, ultimately making this research both exciting and impactful. I hope you take something home from this conversation. Dr. Aleksandrina Skvortsova, thank you very much for taking the time to show up on my podcast. I really appreciate it. Before we get started, I was just wondering if we could talk about your academic background. Where did your academic career begin? Because I do find your CV actually very long, but very interesting at the same time. And how did you get to where you are now?
Thanks a lot for inviting me, Robert. It's true, my academic path was quite long and not very straightforward. So I come originally from Estonia, and that's where I firstly started working as a clinical psychologist, and I studied clinical psychology. And I loved clinical practice, but at the same time, I also really enjoyed reading scientific papers, and I had always interest in science. So after a year of working in the practice, I decided to get some challenge, and I moved to the Netherlands to do a research master in behavioral sciences. And Netherlands has this quite good research master programs. These are 2-year master programs that prepare you to become a scientist, actually. So I've done the program, and after that, I got a PhD place at Leiden University, also in the Netherlands, where I studied placebo effect. And after that, when I was done with my PhD, I received a local Dutch grant for young scientists to go abroad. And then I spent 2 years at Jeff Mogil's lab in Montreal, where I met you. And now that time is over, and I'm back to Leiden. I'm back to the Netherlands, where I'm working as a postdoctoral researcher again.
Amazing. What was your PhD dissertation on, actually? Like, what was the title?
Yeah, so my PhD dissertation was the aim of it basically was look at whether we can find the link between placebo effect and endocrine system. And I've done several studies with a focus on hormone oxytocin. And there was, I can say, like 2 big parts of my dissertation. So one part, we performed a large study in which we looked at whether we can classically condition oxytocin response. And what it means, we try to use placebo effect to trigger bodies of our participants to produce oxytocin. So that was like one big part of my project. And another part of my research was focusing on whether we can influence placebo and nocebo effect by giving our participants oxytocin. So the title of my dissertation was that's a good question. It was a long time ago. I think it was the link between a neuroendocrine system and placebo effect, the role of oxytocin. That was the title.
Okay. Well, we're gonna do a deep dive into that, and so that's actually a good segue. In depth or non in depth, however you choose. What is a placebo and nocebo effect?
Well, so placebo effect is defined as the positive effect of treatment that cannot be attributed to pharmacological action of the treatment itself, and can be rather attributed to some other psychological mechanisms, for example, expectations. And the nocebo effect would be the same, but negative treatment outcomes that cannot be explained by the treatment.
Okay, and what role does classical conditioning have in these two effects? Because I find that very fascinating that there's some pairing pairing system between the environment and someone's expectation that kind of creates this belief.
Yeah, so that's definitely very, very interesting. So there are several ways we can induce a placebo and nocebo effect, and also how they get induced like in real life. So that can be just pure psychological expectations. So, for example, you're getting a new treatment and you're really anxious to get side effects, and you might develop them. So that's a pure expectation. There was no conditioning, never nothing was coupled. You never tried this treatment before. So that's one way. But another way is when you get conditioned, and conditioning means that there is coupling between an, for example, treatment and the outcome. And a good example for that could be a headache, because we all experience headaches. And when you usually get a headache, you can go and take a Tylenol, and your headache disappears. And you've done it many times in your life. So you are actually conditioned to get this certain pill with a certain color and then experience a pain relief afterwards. So there's a really high chance if right now you develop a headache and I'll give you a placebo Tylenol, and that will look like real one. You take it, probably your pain will also disappear. So such a placebo response that is developed through conditioning, through this pairing, is considered to be caused by conditioning.
Okay, and how does that work for the nocebo effect per se?
It can be the same. So, for example, if you look at clinical practice, like the very strong nocebo effect can be described, for example, for chemotherapy patients, because chemotherapy elicits very strong nausea. So, like a day or 2 days after you get chemo, all people get like really, really strong nausea. But what's been found that people often start developing nausea before chemotherapy just by coming to the hospital, because they have this association. I come to a hospital for chemo and then I get like really, really nauseous. The whole environment of the hospital can trigger that. So it would be also a conditioned nocebo effect in this way.
Okay, so essentially what you're saying is that there's this coupling effect really drives someone's psychological state and in turn their behavior as well, and there it doesn't have to. It's independent of the intervention that's going on. Correct.
Exactly, yes. So
Okay.
often intervention is present there, but the effects are not really effects of intervention, but effects of conditioning or expectation.
Okay, and I assume that this happens also outside of a medical context. It's just that it's well researched in the medical context, correct?
Exactly, yes, exactly. And we can also look at placebo effect broader. For example, there are these marketing studies where they let people try wine and say that that's a very expensive wine, and then people describe then this wine as tastier. And that could be also called like a placebo effect, because it's the taste is not really taste of wine, but the taste of the expectation.
Right. And now, how powerful or effective is the placebo effect?
That's a good question, and I think we cannot really answer it right now because it's so context dependent and treatment dependent. So, like placebo effect is investigated a lot in the area of pain, and if we look at, for example, placebo analgesia, so placebo decrease in pain. If we look in lab settings, so when we are doing it in a laboratorium and it's all experimental, actually the effects are quite small. So you might have a decrease in pain approximately like 2 points on the 10-point scale. However, if we look at clinical practice or we look at studies that are more like with patients, for example, or in clinic, sometimes they find way stronger placebo and nocebo effects. And I think it first of all depends on the treatment. Second of all, of course, it depends on how the whole situation is believable. Because if you're doing it in the lab and our participants like don't really take treatments very seriously, the expectations are also not so large. But if you're, for example, a patient who came to get a new treatment, your motivation is really high to feel better, and then the effects can be also larger. So it varies a lot between the studies and
Okay.
between the treatments.
And is there a point where belief and expectations can kind of expire and the placebo effect just stops working?
Theoretically, yes. Practically, again, we don't have so many studies, but we know of this process called extinction in conditioning. So what happens when you get conditioned? So for like we can go back to this example with the painkiller. You're
Mm-hmm.
conditioned that you take a painkiller, your pain goes away. Then you get a placebo pill, and it does work. But then imagine you get next day you have headache and you get the placebo pill. Next day you get headache and you get it again. So probably at some point your body and you also will notice that it's not working so strong, and this placebo effect will disappear. And so that does happen. Also in experimental studies we see that. And for example, for my own research, I had a study with oxytocin when we tried to induce this oxytocin release with placebo. And we did it during 3 days. And on day one, we saw a large placebo effect. And already day two, it was insignificant, but you could see some difference. And day three, it was completely disappeared. So basically, when your body sees that actually this link doesn't hold, the effect disappears. But
Okay.
also maybe important to say that what we find look at, when we look at pain, we see that this extinction doesn't happen so fast for nocebo as fast as it happens for placebo. So unfortunately, the good effect disappears faster than the negative one.
Do we know why that is? Is it just because like stress is very stays in the body longer than I guess higher expectations?
I think so. That's a reason. Probably, if you look at like at evolutionary purposes of nocebo, they might be more like they might be stronger, more important for the body because if you associate something with pain, it's like probably a very important association. You want to avoid this object, so you remember it longer. While when we
Okay.
talk about placebo, yeah, it's good, but like yeah, how it's not so vitally important, probably.
Okay, and then does that mean that the placebo effect is both a cognitive thing and a memory, like a phenomenon, or is it like independent?
Definitely. Yes, I think it's both, and I think it's very hard to put the line what is cognitive and what is memory, what is just belief, and because, for example, there are studies where placebo effect is induced just by giving positive information. So you
So
might
verbally.
think, yeah, just verbally, yes. Or observational learning. So you see other people improve from a treatment, so there is a higher chance you will improve. But then there is also some learning underlying it. So you do remember what you were told, or do remember what you saw before. So.
Okay, and can animals also experience the placebo effect?
Yes, they can. And I think like many people find it really fascinating because when we think about placebo and expectations, we think about, of course, humans. And it does happen in animals. And of course, we cannot give verbal information to animals, but what we can do, we can condition them. And
Mm-hmm.
conditioning works pretty well. And there are multiple studies in pain, but also studies in other areas, for example, with different drugs. And animals seem to get conditioned pretty well.
Okay, and for someone who's never read an animal studies paper on nocebo or placebo conditioning, how would you condition an animal to experience either placebo or nocebo?
Okay, so we can look, for example, at placebo, and these paradigms are usually called pharmacological conditioning. So you can teach an animal associate feeling better from the pharmacological agent, and that would cause placebo. So there are studies where, for example, a mouse is given an treatment like opioid drug that reduces the pain of the mouse, and then the mouse might be placed, for example, on a hot plate, and that's how we can measure the pain response. And then after getting the opioid treatment and being placed on the hot plate, mice, of course, experience less pain, and then they jump off the plate slower. And then after several administrations of this opioid treatment, we can replace the opioid with the placebo treatment. Often can be injection. So instead of injecting an opioid, we would inject the saline and then put the mouse again on the same hot plate. And what we see, the response to the hot plate with this saline would be similar to the response as if the mouse received the opioid treatment. And for nocebo can be very similar. So a mouse or a rat can be given some painful stimulus in certain environment, and then after repeating coupling this environment with the painful stimulus, just placing the mouse in the environment alone would elicit higher sensitivity to pain.
Okay.
So it's always a coupling with some environment or process of drug administration with the stimulus.
Okay. And do we know what are the differences? Like how much more sensitive to pain do the mice get, or how much less sensitive to pain do the mice get, just based off the study paradigm?
Yeah, so actually, if I look at our studies, the studies we did at McGill, the effects for mice were quite large. So we were investigating nocebo effect and pain, and with by a coupling environmental context, so the special cubicle where mouse would be placed with the painful stimulus. And what we found, I think the pain would increase maybe like 30%. So it's actually higher than what we get from humans lab studies.
Right, and also just to clarify, the pain that we gave to them wasn't very painful, like by other stretches of the imagination. It was, heat pain, which is obviously it can be painful, but it wasn't as intense as like other things that you can definitely do to an animal. So 30% is very
Exactly.
large.
Yeah, it's very large considering also the stimulus. So what we did, maybe to clarify for the listeners, what we do, we have this device that shines a light on the paw of a mouse and it slowly warms up. And the moment when this heat becomes painful, mouse moves the paw. And we can measure this response time, how fast they move the paw. And if there is analgesic effect, so if pain is decreased, mouse can hold the paw longer in one spot. And then when it's opposite, if there is a nocebo effect, hyperalgesia, then they move it faster.
Right. So we're measuring the withdrawal time in that instance.
Yes.
Okay. And what does the neurochemistry of the placebo and nocebo effects look like? Because I don't think I'll never not be fascinated by that phenomenon actually being tracked like neurochemically.
Definitely. So what many people imagine, especially when talking about placebo nocebo in humans, that it's completely psychological phenomenon and there is nothing in the body that changes. But also what I find the most fascinating about the whole phenomenon is that we do see changes, physiological changes. And I think the chemical processes really are linked to the type of placebo nocebo we're talking about. And the most what we know comes from pain research. And what we see that from animal studies, from brain imaging studies, and from pharmacological studies. So there's a lot of evidence that when a person experiences placebo effect in pain, our brain produces endogenous opioids. So what happens actually in response to the expectation or the stimulus or the treatment, our brain starts producing our internal endogenous painkillers. And due to this endogenous opioid release, the pain goes down. And that was also confirmed in animal research. And then for the nocebo effect, it's more complicated, and especially for humans because there is not much research done. But one chemical we could track in nocebo effect is cholecystokinin. And our study at McGill also showed that cholecystokinin is involved in nocebo. And when we block this neurotransmitter in the brain, then animals do not experience nocebo effect.
Right. And could you just give us a bit more context as to what cholecystokinin or CCK does?
Yeah, so I think it's very interesting. It's a hormone and neurotransmitter, and we know it initially from the research on digestion. So it's like not related to pain at all, and it seemed even not to be related much to brain because we have lots of cholecystokinin receptors in the digestive tract, and they do signal when you are hungry or when you're full. However, later on, so that was known for a long, long time. But then later on, researchers discovered that there is a lot of CCK receptors in the brain. And it wasn't really clear what they're doing there. And further on, like in the recent years, it became clearer that they also seem to be involved in, for example, anxiety and panic. And there are studies on in humans when people get an injection of CCK that they might experience panic attacks. So it seems to have several functions as many other neurotransmitters, and one of the functions might be anxiety. And that's why maybe it is related to nocebo, because probably nocebo to a large extent is caused by anxiety or fear.
Right. And so basically, just to sum it up, when you increase CCK, the anxiety and negative expectations go up, and when you decrease it or block it, the anxiety goes away. Now, just to create some, I guess, distinction, is how different is CCK compared to a general anti-anxiety medication like Ativan or Xanax or anything like that? Like, could those also reverse the nocebo effect?
Good question. So there is no, so that's why we don't know much about CCK in humans, because there's almost no drugs that can be used in humans to block CCK. There was one drug that has been used in some research, Proglamid, and but it's a drug initially made for digestion, and nowadays it's not used. And the drugs that can precisely target receptors in the brain, they are not approved for human use. So we do not know whether if these drugs will ever be approved or developed in the way that they're safe for people. Maybe they could be used also for anxiety, but we don't know that. And then talking about using some other anti-anxiety drugs for blocking nocebo, there is actually research on that. And there is, I think, actually only one study that showed that anti-anxiety drug can block the nocebo effect in humans. But it was
Okay.
just also one study.
Okay. And what might be the, I guess, intimation that CCK might be having a greater role in the nocebo conditioning than like reversing GABA, which is what the anti-anxiety medications do?
What we look, I think it's different mechanisms, right? And we compared that in our animal models, and then we did not find any effects of anti-anxiety medication on
Mm-hmm.
nocebo in mice, even though there is one study in humans that did find the effect. But also we should consider difference between animals and humans, because in humans it's indeed the nocebo effect might be more cognitive, and it might evoke more general feelings of anxiety that maybe by blocking that, going via that route, might work for humans. But when we look in the animal model, it seems that CCK really plays the major role, because when we block CCK in animals, nocebo effect disappears completely, so we don't see anything.
Okay. Awesome. And how can one block the placebo effect?
Blocking placebo effect. I'm not sure if anyone tried to do that, because it seems clinically we want to maintain it more.
Right.
Yes, but we can. It's been done for just to look into brain mechanism of that. So what has been done is there is a naloxone, a drug that blocks opioid receptors, and that's how actually it was proposed that endogenous opioid is involved in placebo. So you can evoke placebo effect with different procedures, for example, giving verbal suggestions or conditioning. And then if you give a person or you give an animal naloxone that blocks their endogenous opioids, placebo effect disappears. So we know that that was how we actually learned that endogenous opioids play a role. So potentially, if you want to block placebo, you can use naloxone.
Okay. And just a question about the anticipation aspect of placebo, because we know that anxiety is playing a role in nocebo, but what is the emotion that plays a role in placebo? Because anticipation and expectations are more cognitive. Obviously, they're interlinked with many things, but do we know what the main emotion or main emotions are playing an effect in placebo?
Yeah, I think I can just speculate on this topic because there is like lots of studies, also studies in my lab that try to find that. We
Mm-hmm.
measure different states, like state anxiety, we measured personality, and we can never find good correlates. Here and there, something comes up. Sometimes it's like optimism, sometimes it's less anxiety, but it's never really correlated with placebo. And I don't know the reason. It could be that in general psychology, this questionnaires to measure emotions or personality are not like really good. It can be the reason. It can be another reason could be that nothing is really associated with it, but
Okay.
we honestly don't know. But one route can be that it can be still through anxiety, but other way around. Maybe it's just being more relaxed, expecting something positive to happen to you. That could
Okay.
be the route.
Okay. And what are the sex differences in the placebo and nocebo effects?
Yeah, so that's also a not very, I don't have a very straightforward answer. So
That's
if we
okay.
start looking at humans, there is a meta-analysis that looked at all studies together and compared men and women and males and females, and they found no difference. So across, if you pull all the data together, there seems to be no sex difference. There are some studies that find some differences, but it's not very convincing. At the same time, when we look at animals, we could study it more in animal model. What we found in our lab at McGill is that actually for nocebo effect, it seems that males are more susceptible for it, and but it depends on the intensity of stimuli that we give them. So in the first study that we did together with you, we found that when we conditioned mice to a context with a pain caused by acetic acid, which is injection of acetic acid in the stomach that elicits pain for approximately an hour. We found conditioned effect only in male mice. And that was also done in one study before, also in our lab. However, when we changed the stimulus, we looked at post-operative pain. We found effect both in males and female mice. So I can speculate that maybe male mice are just more sensitive to nocebo, and with this less painful stimulus, they already exhibit it. But when the stimulus is intense enough, then both males and females experience it.
Okay.
But in humans, we couldn't find it. But also, I feel like there's so many other factors that interfere in this type of research that it's really hard to say.
Okay. And if you could speculate, do you think that the role of testosterone has a role to play in the nocebo effect? Because I remember when I was, when I was writing my undergrad thesis for you guys, I remember I came across this one study where they over optimized, so they removed the ovaries of the female mice and they injected them with testosterone, and then they found that these ovary optimized mice with testosterone in them had the nocebo effect, whereas the female control mice did not. So is that convincing evidence, or is that still very like early on speculative at the time?
I think it's still one study, but it is actually the study I based my further research on. And it's indeed that's what they found. And I think it has some basis. It can be the truth. And we replicated it with further on. So there's a replication of the study. But then when we change the pain stimulus, this effect is appearing both in males and females. And recently, this year, there is one human study that came out, and what they gave, it was with males, and they gave male participants testosterone cream. So they
Okay.
increased their testosterone pharmacologically, and then they looked at, they gave them pain stimuli, and they looked at the expected pain and experienced pain. And what they found that in males, testosterone increased expected pain and also increased experienced pain. So it seems that, and in that paper, they in the discussion they say that maybe testosterone is not really involved in pain perception per se, but it could be that it's involved in making people more vigilant to negative stimuli, because if it makes you expect more pain, that's how in the end you can develop nocebo effect and experience more pain. So I could say we can see, so there was this initial study in the mouse model, but then now there is this study in the humans. So I think it will be very interesting to look into it further, and it could be that testosterone does play a role.
Okay. Do you remember how much testosterone they were given? Like, was it a lot or was it a little?
I think it was like I cannot say now, but I think it was just like a standard one dose that is done given in many psychological studies just to look at the effects of testosterone. But I can share the link to the study.
For sure. Yeah, because I'm just thinking in like a sports context where some, sports have more like testosterone like supplementation than normal. And I'm just wondering if like those people would have a similar effect because they abuse it to the point of like it creates permanent deficits in their body, in their endocrine system. And I'm wondering if that would have a thing or two, like especially in like the combat sports where they do that quite frequently, even though like they're taking pain all the time, but I guess they're conditioned to be used to that. So who knows? But it's a very interesting effect because now there's like a hormone that's taking place for something that's experienced cognitively. So there's more to be done, I guess, in that sense.
Definitely, I think that's a sport is an interesting example. Also because during sport they probably you don't want to experience more pain.
Yes.
But the tricky part with all the hormones is that it's such a delicate balance, and it can be that by increasing testosterone to a certain extent, you have this effect, but if you go over it, you can have opposite effect. So
Yeah.
that's why you really need to look into the dosages, of course.
Yeah, that's actually interesting because in professional wrestling, so like the wrestling that's done for like just purely entertainment, they actually had a lot of painkiller problems because they're like they're working like 300 days a week, and a lot of them are taking bumps and falling all the time, but also a lot of them are on steroids. And it's now that I'm thinking about it, like as a psychological phenomenon, you could expect that would create a massive nocebo effect where they know that every bump's gonna hurt and they're gonna have to take the painkillers right after. So I'm not gonna come to any conclusions, but there could be something going on with that.
Sure.
So moving on, you have a very interesting study with insulins and placebo nocebo. I was wondering if you could go into that because that is actually quite clinically significant, and it's also not that well known compared to the other pain studies that we've done in nocebo. So I was wondering if you could go in depth of how you were able to condition insulin responses in humans.
Yeah, so that's one actually of my favorite studies we've done. The idea was to bring our knowledge from placebo and conditioning to clinical practice and see, okay, we've doing all the studies on healthy volunteers, but can we actually apply it to people who could benefit from that? And this study we used pharmacological conditioning, so what I referred already before. And it's based on the previous research done in healthy humans, in which they showed that healthy person, if you give them injection of insulin or intranasal insulin spray, both work for several days, several times, and then at a certain point you replace the insulin with a placebo. They found that in response to placebo, the blood glucose levels decreased and endogenous insulin levels increased. So basically, by such conditioning procedure, they could make the body respond to placebo as if it was real insulin. So that was a study done in beginning 2000s. And there was actually two studies, one with injection insulin and one with nasal insulin. So we took this idea and decided to see, can we actually apply the same principle and look at patients with diabetes type 2. So for this study, we had two main groups. We had the groups of patients and we had a group of sex and age matched healthy controls. Because the idea behind that was we want to replicate, but we also want to know, does it happen in patients if it happens in healthy volunteers? Because it can be that it works in healthy people, but doesn't work in patients. So we did the same. We had patients and healthy participants come into the lab. We gave them a nasal spray with insulin that had quite strong smell. So for 6 times, so they received 6 times nasal spray with insulin.
In
Next day
just
they
one
come back to
session.
the one session, but there was half an hour between each of the
Okay.
spray administration. And we took blood. We took blood before and during the whole session. The next day they come back to the lab and we replace the spray, the insulin spray with a placebo spray, but it still has this strong smell. And people don't know that it's replaced. They are told you can replace, you can get insulin or you can get placebo. So we're just honest about that they can get either. But we don't say that first day you got this and second you got this. And we give them 6 times again the placebo spray, and we can measure their blood response. So we could not replicate the initial study in the way, the findings that they found exactly. But what we found, the strongest effect that we found was actually in hunger. We found that our conditioned participants experienced actually less hunger after the placebo administration compared to non-conditioned one. And there is some research showing that insulin nasal spray can actually be used to decrease hunger. So basically, by being conditioned to the spray and even receiving the placebo spray, people experienced less hunger. So that was the largest effect. We also did find a small effect on the blood glucose levels, but the effect was quite small. So I don't want to overinterpret it. And it would not be clinically relevant. So it was statistically significant, but it was clinically not relevant. And we did, and it was both in our healthy volunteers and in patients with type 2 diabetes. And also, if I'm not mistaken, there was this significant effect was found only in males and not females. So it seems that there is again some role of sex. We don't know why. But then when I was looking back into previous studies, the most of research is being done in males, even though there is a lot of discussion in science now that we have to include both males and females. Most of the insulin research has been done in males before, so it could be that our findings that we find effect in males and not females actually reflect what was before, but it's just previous studies were done only in males.
Mm-hmm. Okay, so I have a few questions about that. I guess the first one is, do we know if, this is a very ignorant question, but do we know if the blood glucose levels in males and females are the same or are they different? Because maybe the drops could vary in that sense, right?
I think there is no big difference, so that should not matter.
Okay.
And the baseline wasn't different either, so we looked into that.
Okay. So just out of curiosity, how did you mask the insulin, like make the placebo insulin nasal sprays?
So we worked with pharmacy. So we have pharmacy prepares every time for each of our studies. We have pharmacy that prepares our placebo with to mask it for the drug. Here in this study, there was a limitation that if you would compare the spray of real insulin with the spray of our placebo insulin, if you put them next to each other, they would differ a bit. And unfortunately, it was really impossible. We tried to make them exactly identical. We managed to do it in our oxytocin previous study. They were identical. With insulin, it didn't work out. They didn't have one of the elements that was in insulin for our placebo group. However, to control for that, we asked people what did they think they received, and we asked if they smell difference, and no one could see the difference because it's given on 2 different days, so people probably forget. But we were worried about that for sure.
Okay. And in terms of experiencing placebo effects, would the injection of insulin or its placebo give a stronger response than an intranasal, spray?
I think that could be another critical point of the study is that intranasal spray has very small effects, and we don't know if the real injection would matter, but I think so because injection is a very strong stimulus, and also getting insulin right in your blood causes the effects immediately. And that was the reason
Right.
also why, yes, because it's immediately in the blood. From the
Mhm.
nose, it takes time to get into the blood. So that's why we did it 6 times within one session, because it takes time to accumulate.
Yeah.
Yeah, but
Okay.
basically we had mostly the ethical reasons not to do insulin injection, because people with diabetes, they might respond to injection quite with severe side effects. You can get into hypoglycemia, very low
Mm.
blood sugar levels, and that can be really bad. So people
Yeah.
can lose consciousness,
Yeah.
and so that was the reason we went for a safer option.
Okay. And you brought up something very important, which is statistical relevance versus clinical significance, or statistical significance versus clinical significance. What is the difference between the two? Because this is a very important topic in medicine that's not discussed too often.
Yeah, so if to say it like in a simple way, statistical significance is the significance you get in our statistical results. But clinical importance or difference is something you as a doctor would say, okay, that really matters. Or you as a patient would say, oh, I feel difference, I feel better. If we're measuring pain and you decrease, your pain was 6 out of 10, and after my intervention, your pain became 5.85, probably it wouldn't matter for the way you feel, right? Probably, okay, it's still bad. It was bad, it's still bad. And the same as a doctor, you would say it doesn't really matter. And what happens sometimes in the research, that we do find that statistically the difference is significant. So we do see difference between two groups, for example, or two measuring points, so before the drug and after. And it's consistent and it's significant. However, if it's the difference actually very small, the whole discussion can come: does it really matter for the clinical practice? Should we use this drug, or should we use this intervention, spend time on it when the patient doesn't feel difference?
And do we have a clear measuring, like a clear measure as to what clinical significance is besides the patient feeling better?
There's like a lot of discussion about it, and in medicine they also have some parameters when they say, okay, from this cutoff point it could be considered clinically significant. In placebo research, because we are still looking into mechanisms and we're still investigating how does all works, we don't really look at clinical significance so much at
Okay.
this point, because it's such a it's not very new field, but it's still developing field, and we're trying to understand such complex mechanisms. So we are mostly interested in clinical, in statistical significance. But then when I'm talking about this study with patients, I think it's important to just be honest and say, okay, we have some statistical differences, but I don't think the patients would really benefit from it.
Okay.
So it's too
Okay.
early to go to clinic and tell them you can use this procedure.
Okay. And earlier on, you mentioned your work in oxytocin and placebo. I was wondering if you could kind of chime in onto that, because these days oxytocin is a big word.
Yeah, it is definitely a big word, and it's been for the last few years actually. So we did a very similar study to what I just told you about, but with oxytocin. So we tried to classically condition, pharmacologically condition oxytocin response. So we had people come into our lab on for 6 days, and 3 out of the 6 days they received a real oxytocin nasal spray, and that's the way oxytocin is being administered. And the next 3 days, the oxytocin spray was replaced with a placebo nasal spray. And we measured several parameters. We took saliva samples, and we looked at endogenous oxytocin levels. We gave them several tasks that were previously related to oxytocin, behavioral tasks, and we also looked at the brain imaging. So we had like this lots of measures. And in this study, we found quite strong effect in oxytocin on the day when real drug was replaced with a placebo. So we saw that our participants responded to placebo as if it was a real oxytocin, and the response was quite large. And what I already mentioned, that on second day when they come back and receive placebo again, the effect was dropped a lot, and then the third day disappeared completely. But
Okay.
that was an example of successful pharmacological conditioning.
Okay. And how much oxytocin were you actually giving them?
If I'm not mistaken, it was 24 international units, which is a quite standard dose for behavioral research.
Okay. And how can, like, what is that? What are the psychological effects of giving 24 IUs of oxytocin?
So that's also, I feel like now there is more discussion in general on the effects of oxytocin, especially like behavioral effects. So there was first a lot of research showing that, for example, 24 international units would make you for example, be more kind, donate more. There are studies showing that it affects how trustworthy you find other people. So after getting oxytocin, people would rate faces of other people as more trustworthy, as more attractive. So there were all these studies showing like social positive effects. But I must say, many of them were not replicated. So, and I think that actually behavioral effects probably are really small. This kind of measurements of effects of oxytocin on how much you trust people, they're not very reliable. There is also interesting research showing that, for example, giving this dose makes people more friendly and open to the inner circle, to people who are like you, but be also more racist and more aggressive against people who are less like you. So that's also quite I find very interesting research. So when
Okay.
we talk about oxytocin as like very positive hormone, it's not. It has a flip side.
Interesting. That's not actually counterintuitive when you think about it. If it makes you
Yes.
more closer to your in group, it's probably going to make you also more hostile to more out groups. Okay, that's interesting.
Yeah.
You also did a lot of research on measuring, like you did a systematic review on measuring placebo effects and nocebo effects. And one conclusion that you had was that there's a lot of heterogeneity, which is a good thing, but it's also a little problematic. And I was wondering, in your opinion, what is the ideal study paradigm to measure placebo nocebo effects in both either humans or animals?
Well, I think it's first of all we need to decide well what placebo nocebo effect and what symptoms we can measure. So
Mm-hmm.
that's like a first important point. But regardless of the symptom, if it's pain, is if it's diabetes, metabolism, if it's any other symptoms, I think the most ideal way is first it's a combination of conditioning and some positive information about the treatment. And there is quite some research showing that the combination it works the best. So you could be conditioned, so given a real medicine, but also given very positive information about this medicine. So if we're talking about painkiller, you could be getting for several days, you would be getting a real painkiller with maybe very friendly doctor who's giving it to you, bringing you very positive, optimistic information about it. And the combination of this environment and pharmacological action and pharmacological conditioning, I think, would lead to the stronger placebo effect.
And what about in animals? Same thing?
In animals, yeah, we cannot create, of course, this psychological part like
Mm-hmm.
information or environment. But in animals, what we see, the more repetition, so more times you couple your conditioned and unconditioned stimulus, more times you get the real drug to the animal, the stronger the effect will be.
Okay, okay.
Because it's learning, right? The more times you repeat something, the higher
Right, right.
the result.
And you place an emphasis on verbal suggestions for to give not to give but to like create the sense of placebo effects. Is verbal suggestion the only thing, or could other like elements of the environment influence that as well?
Definitely, there are multiple elements. So the verbal suggestions is like a simple way. It's like what your doctor tells you, what how you bring the drug. But there is other elements. So there's quite some research done now on so-called observational learning. So what you learn from other people. So
Mm-hmm.
if you know your family members benefited from some treatment and you've heard a lot from media, for example, probably your chances to benefit are higher, that you'll have a higher placebo. And the same with nocebo when the media is like super negative about some treatment.
Mm.
And you can learn from it and probably expect worse. But also, we are doing quite some research on communication and communication from healthcare professional with the patient. So I think it also really matters, and it doesn't necessarily need to be a verbal suggestion about treatment, but it can be the whole environment. So when you feel like your healthcare professional is caring, they're there for you, they're supporting you, probably it will enhance your placebo effect.
Okay, and so essentially, even just mere exposure can cause those type, not necessarily cause, but it can influence those effects, whether it's both positive and negative. So it's both ubiquitous, but it's also very sensitive and specific at the same time.
Exactly.
Okay, okay. And also, are there like instances where a positive, so like a medicine that you take regularly that you experience like positive uh, like reactions from, so like let's say Tylenol for example, is it common where it can eventually turn into a nocebo effect where the positive just starts to decrease slowly and turns into more of a negative type of experience?
Well, we do not have any research on that, but if I can speculate, I would say that not really, unless there is some other very strong negative event coming together with it. So, for example, you taking your Tylenol, but at the same time you got like you ate something bad and you got very sick.
Mm.
Then your body probably will not discriminate between what you ate and your Tylenol, and then it can flip into nocebo. So I think if there's some other very strong negative stimulus it would intervene and come together with your normal treatment, that can flip into nocebo.
Okay, okay. And I guess another question about conditioning is how can people kind of influence their own conditioning? Not to be like super rudimentary, but like super like rigorous about everything, but how can someone kind of decouple or couple things together to
Well,
increase
that's
placebo? Yeah.
Yes, we do not, again, like from research point of view, we have not done any studies on that. But if myself had to do that, maybe I would try to like take my treatment in some kind of more positive, relaxed environment, just to make sure that there is no other factors that could negatively intervene with it. It can be also just your mindset, how you set yourself up for your treatment and your expectations. Maybe, yes, if you're worried about the negative effects, maybe you want to talk to someone who did this treatment before, or talk to a healthcare professional, just to decrease your worry before you start taking this treatment. So it's more like taking care of your mental state around the treatment.
Okay.
But
And
also maybe to say something like, if you want to try something like very experimental, for example, we know that the color and the size of the pill can influence your conditioning. So for example, if you're trying to get conditioned to painkiller, and if the painkiller is bright red or pink, probably it will get conditioned more because the stimulus stands out more. And some painkillers are pink. So it could be that
interesting.
the pharma companies are using it already.
That's true. Some forms of Tylenol are red, at least here they
Yeah.
are. So a question I like to ask scientists is, if money was no object, what would be like your ideal study design?
That's a good question because money is always a problem.
Mm-hmm.
So I think I would. I'm very interested how we can use this knowledge we have on placebo and nocebo and actually bring it to clinical practice. So I think I would start with a really open question, and I would just pick a group of patients. For example, yes, I'm doing now research in diabetes. So I would just interview patients with diabetes and explore their expectations from the treatments they're getting. Let them just talk freely and see what factors actually matter for them. And maybe there are some anxieties or some expectations that we don't really know about. So that would be like a first step. And then after analyzing that, I would love to work maybe together even with a clinical psychologist, and we could design some intervention for this group of patients where we could use, on the one hand, all our knowledge from conditioning and placebo, but put some more psychology and more some elements of psychotherapy to it. So combine maybe a treatment, conditioning, together with maybe one consult with a psychologist who would talk you through your treatment and address all your worries and expectations. And I think that would be something I would be very interested to do, just creating like an optimal intervention using placebo, but also using other elements.
Okay, that was actually the follow-up question I had is how can clinical psychology leverage placebo effects in the same way that medical doctors kind of do that as well?
Yeah, so that's something also in my lab we are working on a lot, and is we try to bring this information on our research on placebo to clinic and teach healthcare professionals that. And it can be used, first of all, in the ways for just managing expectations of the patients. It's very important before any treatment starts to assess the expectations and assess the fears of patients, because often we get prescribed some drugs and no one is asking us, are you okay taking this drug? Are you worried for something? So just assessing the anxiety and expectations and maybe managing them to some extent. Of course, we don't want healthcare professionals to lie intentionally to the patients, promise them something that's not realistic, but it's still possible to emphasize the positive parts of the treatment. So I think that's one of the ways, for sure, that it can be brought to the practice. But another way is we could also, if we take our pharmacological conditioning studies, I think it's a great way to see how we could implement this idea into, for example, tapering of medications. So for some conditions, you take certain drugs and then you need to stop taking them. And we could use this pharmacological conditioning paradigms to taper the drugs. So, for example, not stopping immediately, but reducing the dosage.
Right.
Also, we could use conditioning for trying to boost the drugs by just including these elements of classical conditioning to normal treatment plan. So I think there are many ways you can apply it. Sure.
Okay, awesome. And at Leiden, you guys have recently opened up the interdisciplinary placebo studies. Is it an institute or is it a unit? Like, what's the since it's so new, I don't know how to actually categorize it.
So we call it a center, and it is actually our like lab. It's our research group
Okay.
in which we work. Yes, and
Okay.
we call it a center.
Okay, awesome. What does this center hope to achieve, and what are your guys' current projects right now?
So the aim of the center is, of course, continue studying placebo and nocebo effect from many levels. So we are very interested in more experimental lab research to understand the mechanisms of placebo and nocebo. But then we're trying to bridge this gap between clinical practice and lab research. So we are focusing a lot on to bringing this knowledge to clinic, to design studies for patients in which we can leverage placebo effects, but also create educational programs for healthcare professionals and teach them to use the knowledge we have.
Okay.
And yeah, you asked also for the projects that we have right now, and yeah, they vary. So we do have still a lot of experimental labs, studies. We have several people working on pain. We have people working on itch as a symptom. We recently received a large grant in which we will try to apply pharmacological conditioning for arthritis patients. And we do work a lot on the area of communication. And we have created in past, and we continue working on creating educational programs for healthcare professionals to teach them to use principles of placebo, but in general, principles of psychology in their practice. So we have like many divisions.
Okay, yeah. See, it's very interdisciplinary. Do you guys collaborate with other universities by any chance, or is that like later down the road?
We do. So we are a member of SIPS, which is a Society for Interdisciplinary Placebo Studies. And the society includes basically all the labs across the world that do any placebo and nocebo research. So we do have lots of collaborations also within Netherlands and abroad. So that's also a big focus for us.
Okay, and since you're delving into like the realms of like clinical psychology with placebo effects, which I think is very cool, and unique at the same time. I'm wondering, what are like the limitations of that? Are there certain cohorts of patients that have certain disorders that are just very non-responsive to this type of intervention?
I would not be able to say which patients are not. For sure, I think for somatic health, it would be clearer because for sure there are some somatic conditions that are really somatic and there would be like impossible to influence. For example, if we talk about cancer. But at the same time, even if we talk about cancer, there is a lot of nocebo effects in cancer, what I was mentioning before, for example, with nausea and fatigue. And that's something we could still target. So I wouldn't say we don't have any studies that would compare different groups of patients and say who is responsive, who is not.
Right.
But there are definitely limitations. So we know that, for example, placebo does work, but the extent to which it works and this clinical relevance varies across the studies. And it's never like, it's not huge ever. So it can be very small or it can be just small. But then how we see it, we see that we don't have to use just pure placebo. What we can use these principles to enhance the existing medicines. We're not aiming to replace the medical interventions that we have.
Right.
It can be just like add on.
Okay. And you also have this other program that you're working with, which is the Framework for Open and Reproducible Research Training. I was wondering if you can go into that, because as someone who also backs open science, I would just love to kind of have to publicize this.
Yes, so the name of the organization is FORRT, and the goal of this organization is to bring the principles of open science into the education. So it's a completely volunteer-run organization, and it's quite large. We have many sub-projects, and each project has their own focus. So we have projects that focus on creating a glossary of open science terms, and this glossary can be used by students and teachers when they want to learn about open science. We have a project that focuses on neurodiversity, and this project is just doing a lot to open the science to people with different neurodiversity. So there's like different projects, and the part where I'm working on is project called Replications and Reversals. And what we are doing, we are building a database of most famous psychological and in general social science effects that exist. And then we are searching for whether these effects were replicated or even reversed. And reversed would be actually that opposite effect has been found.
Okay.
And our goal is to have this database available for students, for educators, but also for scientists. So, for example, if you have to give a lecture on something, you can check this whether the study was actually replicated or not. And I think it's very important to bring this knowledge and some database like that to people, because it does cost a lot of time for educators to prepare for classes, and there's so many studies coming up every day. It's very hard to keep up to date all the time. So you might prepare your class and talk about some effect, and then next year it might be debunked, but you'll never come across that because you're just not able to check all the references that you're using for teaching.
Okay. And is it kind of like its own journal, or more so a repository of, Stanford prison experiment and then all the following studies with it, and to see if things kind of match up or not?
Yeah, it's more like a repository, and it's all completely volunteer run. And we regularly do hackathons where we invite people who would like to participate and ask them to fill in some effects from their field. So, for example, if you're working like in social psychology and you know some effects that were replicated or not, you can add them to the database. And recently we also received a grant, and using this grant, we will develop a Shiny app in which, in addition to just searching the database, you will be able to see like effect sizes of studies.
Okay, that's
and do some
very
statistics
cool.
with it.
That's very cool. And I guess more of like a preceding question is, what is the exact motivation behind this? Like, is such an organization necessary in our field, specifically in psychology?
Well, I could say like my motivation also for using it, and I guess many of my colleagues there share it, is there are several big problems in science, I think, nowadays, and that are we trying to address with this movement. So first of all, is just accessibility. The science is done mostly in developed countries, in Western countries, and the papers are published very often in the journals that cost like hundreds of dollars to get a subscription for. And many people who want to do science, they just don't have access to that. And it feels very unfair, also considering that all the research we do are coming from the taxpayers' money.
Right.
And that's one of the points of open science. Keep open what we are doing and being able also to communicate to people the results of our research. Another point is also that because of this quite closeness of the science and all these barriers, many studies are done, but no one has access to the data, and no one can actually see how well it was done. Was it rigorous enough? Was it ever replicated? And here also a part of open science comes to play, and that says that we have to keep our data open. We have to have our code open. So anyone, anywhere in the world can get access to the data and try to analyze it again or use it in another study or build upon that. So, and I think it, first of all, it makes science more accessible, but also it improves the quality. If we all are open, if we all can use the data of each other, we can help each other, we can work together. In the end, I believe it will lead to the better science.
Okay. I think data sharing is more common, though. I see that more often in psych and cog sci papers where they have their R Studio code and their Python code all open. So I think that's a very
It's
good
going
thing.
there for sure.
I'm also just wondering how prevalent is the replication issues in our field? Obviously, it varies per subfield, but like in the ones that you know, like are they more prevalent or more so like more sparse than others per se?
Well, you can probably have heard about so-called replication crisis in psychology. So it's been discussed for the last several years that unfortunately the majority of the largest psychological findings were never replicated or cannot be replicated. And we don't know the reasons for that. And there could be many, many factors. It doesn't necessarily mean that the authors are not honest. It can be that the study was done flawed, or it can be also that the phenomenon is not stable enough and differs between the countries, between the samples. But in psychology, it's very, very prevalent that the studies cannot get replicated. But also, I think psychology got this bad reputation for replication crisis. But if you look in other fields, there are also failures to replicate even in pharmacology. So
Oh,
it's
interesting.
actually a bigger problem.
In
So
pharmacology,
the,
okay. Okay.
yeah, so there are many drug studies that find some great effects of the drugs, but then they fail to replicate in another sample.
Yeah, actually, I don't know why I was surprised at for a second, because then I just remember, like, I think 2 years ago there was like the beta amyloid crisis in Alzheimer's that had that
Yeah.
thing, and that was like a huge failure. So yeah, that makes sense. Although even that's in more of a STEM field, right, where you're mixing
Yeah.
pharmacology, chemistry, and biology. So yeah. And do you have any, before we close off everything, do you have anything to promote? Are you perhaps writing a book? Or are you perhaps going somewhere for your studies or anything like that?
Well, if we started talking about FORRT, I would love to promote that because we're always searching for volunteers, to people to join, and we have lots of different projects on go. So I will give you a link. Maybe you can post it below the
Absolutely.
video, and
I
you
will be
can join
joining
our
it.
Slack channel. And there are many projects you can choose from, and also it's up to you how much you want to invest, because we're always searching people who could add a small thing to the database or add a small contribution to any other project, or we're also looking for people who take more responsibility. So
Okay, awesome. Well,
if you're
thank you
interested
very.
in open science, yes, please join.
Okay, awesome. Well, thank you very much for taking the time to interview with me. This is very interesting.
Thank you, Robert. That was a great talk. Thanks.
Thank you for listening to this episode. To support this podcast, please subscribe to my YouTube channel, rate it 5 stars on Spotify and Apple Podcasts, and I'll catch you at the next episode where I either talk to an astrophysicist about the nature of the universe or I talk to a social psychologist about the nature of prejudice. It depends who comes first. Take care.